Okay, well, welcome everyone to another virtual classroom session. Today and tomorrow, we're going to be talking about our MIS safety modules. So I do appreciate your taking time out of your day to be with me here today. I am Peter Arthur. I am the Technical Training Manager for Control Techniques Americas. And today we're joined by a special guest. Mike Durden is on the line with us today. And Mike is a senior field application engineer who works out of our central region. And Mike covers a lot of the automotive industry and people who have used or implemented this safety module before. So Mike is here to answer any questions that I can't field, and to also add things that I may have overlooked. So glad to have you here, Mike. We're as far as the daily agenda today and tomorrow, we'll start at 10 a.m. Central Time. We'll have a break midway through for 10 minutes, so you can get up and get coffee, whatever you need to do, and we'll be finished up by noon. If you have questions, unlike a lot of the webinars or what have you that you've seen, if you have questions, please unmute yourself and speak right up, and I will attempt to answer those questions for you. And again, if I don't know, I'll ask Mike, and if neither of us know, well, we will get the correct answer for you, and I'll get back to you via email. As I mentioned, I am recording this, both sessions, and I will be posting the recordings to the Americas YouTube channel when we're finished. So today, what we're going to look at is an introduction to machine functional safety. Then after that, we'll look at some of the features and functions of our MIS safety modules. Then I'll have an introduction to functional safety, and we'll have a review of the supported machine safety functions. One of the things I'll tell you right off the bat is, in looking at the documentation and the literature for this particular module, there are a lot of acronyms, which I'm not a big fan of, but I'm going to do my best to try to steer you in the correct direction as to what these acronyms mean. So MSF is the first one you're going to see, and that is a machine safety function. So that's what we'll do today. And then tomorrow I'm going to work with our Connect software to show you the safety application editor. Actually, it's called a safety setup. So it's not a safety application, it's a safety setup. So I'll show you Connect tomorrow. And now we'll go through some more of the acronyms tomorrow when I actually get the software. And then I have a worked example here of an MIS safety setup, and I'll walk through that, and hopefully that will help you to understand a little more about how this particular module functions. So that's what I'm going to be covering for the next couple of days. And I need to begin with a disclaimer. Now, Control Techniques employees, including myself, are restricted by the following regarding what we can and cannot do with the MIS safety module. So I'm going to be talking about that here. Whoops. So to begin with, I'm going to talk about what I can't do. And it's not just me. It is any Control Techniques employee is subject to this disclaimer. So to begin with, no CT employee can confirm or approve, nor give the impression of doing so, any given arrangement as being correct for the application in terms of safety-related control system, meeting its requirements. So in a nutshell, what that means is no employee of Control Techniques can make a statement to the effect that your particular safety setup is in fact safe. We are not qualified to do so. We can also not take on any responsibility for any safety-related design matters. So I'm going to discuss the process of coming up with a safety analysis, but in the end, no CT employee can bless a safety-related machine design. That is entirely beyond the scope of what we are able to do. But on the other side, what I can do is I can offer, we supply products with safety functions of, drives and safety modules. Yes, we do. I can provide clarification and advice, which is what I'm going to be doing. Excuse me. Regarding the specification, integrity data, and installation instructions for the module. I can provide clarification and advice regarding the functionality of the option and programming tool. So, hence this session, I'm going to show you how it works. I can assist you to ensure the information provided is correctly interpreted. I can also seek to identify opportunities for applying the functions. And generally, I can show you how it works, and I can provide you with an example, but we cannot approve any sort of safety design or specification. And even in all instances, it's clear that what I'm telling you today and the examples I'm giving you are provided in good faith. All right, so in other words, I put these together to the best of my ability, and that's what I intend to do for the rest of today and tomorrow. So that's a lot of legalese looking stuff there, but it's important that we make that statement. So to begin, let's look at machine functional safety. So functional safety entails the detection of a potentially dangerous condition resulting in the activation of a protective or corrective device or mechanism to prevent hazardous events arising or providing mitigation to reduce the consequence of the event. So in a nutshell, that is what functional safety is. So if you look at the diagram here, in the design of a machine, a risk assessment must be performed and then updated. So with any machine design, and where safety is important, and I can't think of an instance where it isn't, you must perform a risk assessment and update it regularly. So as far as possible, the machine should be designed to be inherently safe. So in other words, after the risk assessment has been completed, now you know the potential design, potential safety issues that might arise from your design. So during the safe machine design, you are going to attempt to design the machine to just mitigate or eliminate those hazards that have been identified during the assessment. And then in many cases, there will be risks remain after, even if the design is chosen to be proven. So in those cases, what we're going to do is we're going to employ some suitable control measures. So functional safety is more than just a risk assessment. You need to ensure that your machine design is valid, and even given that, there will likely be some things that need to be addressed afterwards in terms of safety, and that's where the MiS modules come into play to help to either eliminate or mitigate those remaining risks. The other thing I want to point out here right off the bat are these regulatory agencies. I'm going to be discussing these a little more in detail as we go along, but there are, of course, standards organizations, that are involved with the specification and the creation of machine functional safety. So our safety modules are designed to comply with standards that are set forth by these groups. You'll see ISO, which is the International Standards Organization. You'll see IEC, which is the International Electrotechnical Commission. And specifically, our modules comply with IEC 61800-5-2. Now, IEC is the regulatory agency that is going to define safety integrity level, or SIL. So if you've used our drives, our M700 drive, for example, our high performance drives, or our Commander C300, either one of which, those are designed with safety in mind. Our Unidrive M702 and the Commander C300 are designed to achieve SIL level 3. The other organization is ISO, and ISO defines the PL, or performance level. And again, with respect to our Unidrive M702 and the Commander C300, those products achieve a performance level of level E, which is the highest level you can achieve. So I want to differentiate that our drives meet these safety standards. The MiS module is there to provide additional safety functionality. So where does the safety module fit? Well, the safety modules provide motion safety functionality in association with standards on the previous slide. The function of the safety module is to monitor the signals present at its inputs and activate its outputs in accordance with the machine safety function, MSF, algorithms provided in Connect software. What you're going to learn here is that these MSF algorithms are what you're going to use to build your safety setup. The algorithms that are in Connect software are a subset of those provided by PLC Open, which is yet another international body, Safety Part 1. So our people, our engineers in the UK, these safety functions that we're going to be using were not designed by Control Techniques specifically. They are, as I've said, a subset of what is present in PLC Open Safety. A question I had when I first started looking at this particular module, and I've been in the industry for quite a while, and I've heard of machine safety, I've heard of safety PLCs, I've heard of safety controllers. So when I first looked at this module, I thought, gosh, is this a safety PLC, or what is it? And the answer to that is no. It certainly is not. The MiS module is not capable of addressing any safety concerns that do not directly affect the drive it is mounted to. So unlike the safety PLC you see there, which can take inputs from all manner of safety devices and sort of do a comprehensive machine-wide safety application, our modules are integrated or decentralized, which means they are local to the drive it's mounted to. And in fact, its only purpose in life is to control the host drives, either a Unidrive M700 or a Digitex HD's safe torque off contact. That's what it can do. So not to be confused, can you replace this safety PLC with an MiS 250? In most cases, no. So it is specifically designed for the module or for the drive it's mounted to. Now, in terms of the modules, we have two different modules. So in this section, we're going to define what the safety modules are. We're going to define what functional safety is. I'm going to address where these modules are used, why they are used. We'll look at the module hardware. I'll talk about the module firmware and module installation. So to begin with, the family of safety modules enable motion safety and network safety for Unidrive and Digitax. So not only can we do local safety, we can also utilize two different networked safety protocols. This module supports FSOE, which is functional safety over EtherCAT, and it also supports CIP safety, which is the Rockwell/Allen Bradley safety standard, or safety protocol, I should say. Now, in this presentation, I'm not going to be getting into the specifics of either of those. I'm going to provide an example of using Connect to set up a local safety setup. But what I will be doing going forward is producing YouTube videos that show you how to use this module with both EtherCAT and with a Rockwell PLC. So this particular module does have a very complete list of supported motion safety functions. We are one of the few vendors supporting more than one network safety protocol. So again, we can do EtherCAT and CIP safety. The safety functions are simple to parameterize, and once you see how it's done, I think you'll agree, and they are flexible within their design limits. So that's basically what the MiS safety module is. So integrated, again, it's integrated safety. So we support the decentralization of motion safety functions for a machine. And some of the benefits are reduced complexity and design time, reduced wiring, because we can take care of the safety functions at the drive level now, instead of having to run everything back to a central PLC. Ease of commissioning and the speed of action. Of all of these benefits, that last one is probably the one that's most important. We minimize the latency, signal latency, by having the safety sensors wired directly to the module, instead of having them come through a PLC and then using safe outputs from the PLC to come into the MiS module. Because everything is local, we can eliminate any PLC overhead or latency that could result. So that's an advantage of keeping the safety function at the drive level as it relates to the drive specifically. So the design now. The conventional approach to functional safety relies on external safety controller that you see here. Let me get my pointer fired up here. So here you see there's a traditional safety controller, safety PLC. And you see that we have a couple drives here being powered from the mains, and there's contactors on the input and contactors on the output side of the drive. So integrated safety reduces the cost and design time, specifically by the fact that our drives, the Unidrive M700, the Digitax HD, the Commander C300, have onboard safe torque off rated contacts. The use of those safely switches off torque to the motor. So because of the fact that we have the onboard STOs, there is no need for a contactor on the mains side, nor down here at the motor side, just by the use of our onboard STO circuits. Further, the addition of a safety module enables complex safe motion monitoring. And what you're going to see, the example I'm giving tomorrow is fairly simplistic, but what you're able to do is you are able to sort of cascade these motion safety functions into one another to come up with a more complex safety motion monitoring. And further, when an external safety PLC is required, you can still integrate our drives easily using a safety field bus. And again, that can be EtherCAT, and that can also be CIP safety. So all of these, for these reasons, we like to think of our product as being very capable and conforming to the standards set forth by these safety agencies. Now there are two models, and this is very important for prospective users. There is the MiS 210. That module may only be used with a Unidrive M600 or a Unidrive M700, as you see here. All right. Further, and today, and for my examples, I'm using the MiS 250. The MiS 250 is for the Digitax HD that you see here. Now, these modules are specific to the drive, and they cannot be interchanged. You cannot swap them around physically because, again, I'm using the MiS 250 today, but there are some mechanical features of the 210 that will prevent it from working on the Digitax HD. So right off the bat, that's the most important thing to know. Make sure that you've selected the correct module for the host drive that you intend to mount it to. These modules have a lifespan of 20 years, and that's called out in the installation and operating guide. And on power up, the module runs a built-in test to ensure the module's integrity. So in the manual, in the maintenance section, they recommend that the module be powered off at least once a year to ensure the integrity of the module itself. But it has a predictable lifespan of 20 years. Another thing that's important to note is the firmware in these modules is not field upgradable. So unlike our other SI or system integration modules, whose firmware can be updated in the field, this particular module cannot be updated for obvious reasons. It's a safety module, and we need to limit outside interaction as much as possible. So MiS 210 and MiS 250. So minimum requirements. To utilize the MiS 210 with a Unidrive M600 or 700, the firmware in the drive must be at least revision 1.16, right? And the drive date code, which is shown over here, the serial number is there, the date code is there. So the date code must be greater than 1807. So if you've got an existing M700 with newer firmware, or it's a newer drive, the module will work just fine. But if you've got an older one, even though you can update the firmware, you can't do anything about the date code. So make sure before specifying that your host drive, the M700 in this case, qualifies on both of those points. Further, the factory fit Ethernet module. So the M700 Ethernet firmware has to be greater than 211.0.16. M600 with SI EtherCAT, the or 700 with SI EtherCAT, the firmware has to be greater. EtherCAT firmware module has to be greater than 107.04.02. And then with Connect software, you need software version 2.13 or greater for version 1. Now, version 1 machine safety, there's actually two versions of this module. V1 is the initial release of the module, but anything you're getting now is going to be version 2. So to use Connect software with a new module, Connect software needs to be at least at 2.17.0036. So there are two different firmware versions of this module, version 1 and version 2. So anything going forward will be the newer version. Now, for the 250, the Digitex HD firmware has to be greater than or equal to 123.00. All right. So you see this is the sticker that you'll find on a Digitex drive. The drive date code, again, is 2130, has to be greater than 2134. So this particular sticker right here indicates that this drive is not capable of using the module. It's got an earlier date code. Now, the HD 750 has factory fit or built-in Ethernet. So the firmware revision of the Ethernet on the drive has to be greater than 211.0016. Then the 753 is the EtherCAT drive, and there's the minimum firmware revision for that to work with an MiS 250. And then the HD with M750 with an EtherCAT module. So if you have an M750 drive, not the 53, with an SI EtherCAT module, the EtherCAT firmware in the module has to be at that level right there. Now, here is where the distinction between these two modules really comes home. We're looking at an MiS 210 module here, which is going to be installed in a Unidrive M700. So what happens with this module here, let me see, do they talk about? First thing you do is on the M700, and I've seen this from the beginning, there's a little white label here. It's not blue. It's a little white label here with a little picture of a book on it. And I always wondered, gee, I wonder what that is. Well, now we're going to find out. Because if you're using an MiS 210, you peel that label back, take it off, and what you'll see underneath is a female receptacle for the blade connector, which is on the back side of this module. So I don't have a good picture of the back side of the module, but if I did, you'd see a male card edge connector sticking out the back side of the module. Well, that plugs into the receptacle that's underneath that sticker. So that is why you can't interchange these modules. It simply will not work on a Digitex drive mechanically. And when you do, when you plug this in, now this module has full control of the safe torque off connections on the drive. So regardless of what you're doing otherwise, this module is now in control of the safe torque off connections. Right. Oh, there's an extra piece right there. Right. So you remove the label. There's a plug in that slot. So you pull that plug out of there, then you mount the module. Now an MiS 250 in the Digitex HD is completely different. Further, the first thing is you'll need this expansion module kit for your Digitex HD for sure, because you need to be able to mount a module. And without this green kit here, you won't be able to do that. So with this module, there's the part number for the mounting kit right there. So you'll need that. And then the MIS module is designed to be used fitted into slot 2. Slot 1 has the bottom side of the expansion module pointing upwards. Slot 2 has the connector pointing forwards towards you as you're looking at it. And the reason for that is, unlike the MIS 210, which has that blade connector which automatically accesses the safe torque off circuits in the host drive, with an MIS 250, you need to include a wired output from the module, as this picture shows, from the safety module to the drive safe torque off contact on the I/O terminal strip for the Digitex HD. So again, that's a very important distinction, that you must put the MIS in slot 2, and further, MIS 250 in slot 2, and further, you'll require a wired connection from a safe output on the module to the safe torque off contact on the drive. And that's what this is the arrangement that I have here today, and I'll be showing you tomorrow. So very important. Now this wire can connect to either of two different spots. We're going to learn there are two, and here's another acronym right here, SHOS. That is a safe output. So SHOS designates one of the two safe outputs on the MIS module. And that wire here can be connected to either pin 8 here or pin 14. The module has two safe outputs. And on the other side, on the Digitex HD side, you can connect your wire to terminals 2 and 6. So here I've got it in terminal 6, it looks like. Now here's the front view of the module. So, did we show that? No, we don't. Yeah, we don't. MIS 210. Oh yeah, here it is. So right there's that connector that goes into the receptacle under the sticker. Well, it's just not here on the 250. So this is what it looks like, two connectors. And this is what tripped me up, as Mike will attest to, and I'm going to hope to clarify what tripped me up here in a little bit. So the green connector is your digital input and output connector. And then the other connector is for a second encoder. And we're going to be talking about encoders as we go along. There's the blade connector. There's the drive interface connector for the 210 and the 250. Now, to wire these modules, in the manual, and this is what tripped me up, by the way, in the manual, you'll see this nice picture where the terminals are labeled 1, 2, 3, 7 to 14. These nice little labels are not on the connector. All right, there are no terminal numbers on the connector itself. So the orientation of the module is very important. So in this case, I'm showing you the orientation for an M700. So it's mounted vertically. So the pin numbers, there's pin 1 through 7 on top, and then 8 through 14 on the bottom. So the orientation is very important. The black connector is for the encoder connections. And once again, the terminals themselves are not labeled. So the orientation, in this case, would be for a Unidrive M6 or 700 because it's mounted vertically. Now, if you turn it sideways, here's where things get interesting, because when you put it in slot 2 of an MiS 250, then the orientation is as shown here, right? So now here are the encoder connections, right? Here are the I/O connections that you see here, right? So pin 1 is over here now. So keep that in mind. So there's 1 through 7, 8 through 14. I'd also recommend using 22 gauge wire, and ferrules are critical. I don't know that you could do anything else. You need to use criticals, or I'm sorry, you need to use ferrules, because these terminals that you see here are the push-in spring-loaded type. So you plug your wire in, your ferrule in, doesn't require you to do anything other than to plug it in. To release it, there's a small button here that you use a small flat-bladed screwdriver to release the spring, and then you can pull the wire right out of the connector there. So little tips for success that'll help you get this going as we go along here. Pay attention to the orientation and the terminal numbers when you're doing your wiring. Now, there's an example of using two safe inputs, right? You'll see in this diagram here, and you'll see over here too, input 1A, input 1B, input 2A, input 2B. Those are designed to operate as pairs, right? Safety, a big part of safety, machine safety, is redundancy. So that is why there are complements provided for the two digital inputs. Yes, it would appear that there are 4 inputs, but they are treated as pairs. So they both must be true in order for the safety circuit to acknowledge their presence. And I'll show you what happens otherwise tomorrow. But they operate in pairs. And then we also have these pulsed outputs. Now I'm going to talk more about the pulsed outputs that you see here. But the pulsed outputs are an alternative power supply for the inputs. You can either wire, as I did in my demo, external 24-volt power supply to this side of those inputs, or you can have them powered through the pulsed outputs that you see there. Now there's an advantage to doing it this way, because another feature of safety is when using these pulsed outputs, the integrity of this circuit is checked. As soon as these switches not only operate in pairs, but these switches are designed to be normally closed. So I don't know how you want to think about that, negative logic or otherwise. Not negative logic, but these are normally closed by default. Or that's how they're designed to be considered, as their on state would be when they're open, right? So as you see here, this would indicate an on state. When it's closed, it's off. So when it's closed and using these pulsed terminals, the controller here will send a low frequency, low voltage pulse train all the way through this circuit to check the integrity of the circuit itself. So using the pulsed outputs, it's just an added layer of safety. Now, I did not do that in my demonstration, but know that that's what the pulsed outputs are used for. Or on the other hand, as I did, I just used a external 24-volt power supply and wired it straight as you see there. So either way works. This is perhaps a better way, but either way works. Now, in terms of encoders, so motion safety can be implemented with up to 2 encoders connected to the drive, right? Now, those of you who have used our products know that our high-density 15-pin connectors for our encoders can be configured as 2 separate channels with 2 separate encoders. But all that depends on the type of encoder that you're using. So here is a list of the primary encoders that we support over here. And you'll see that that's all channel 1, on the 15-pin port, right? And then as a secondary encoder, we can use AB, which is just that's not Allen Bradley, it's a standard quadrature encoder on channel 2, SSI, sine cos, and the list goes on. But what's important is the achievable SIL, safety integrity level. This does not say that just the addition of these encoders is going to give you SIL3. No. It says that it is achievable, that level is achievable when you're using this combination of encoders. So that's how you would interpret this particular table that's shown here. Now what I did was I used the drive encoder only. And the reason I did that was because it's much cleaner. What I'm going to introduce tomorrow is the concept of encoder snooping. So rather than having a second encoder as the source for my safety setup, if I use the correct encoder, which is either a safe NDAT 2.2 or a standard NDAT, which is what I have, 2.2, I'm able to sample or snoop these without the need for a secondary encoder. Now I can add one if I want to. In fact, if I want to get to or have a chance to get to SIL3 using this combination, I would have to add a second one and wire that to either the drive itself. Well, that's what we did here. So 2 NDATs coming into the high density 15-pin connector on the drive. Or I can go primary, secondary, drive, and local. But once again, notice NDAT 2.2, SSI, sine cos, or quadrature. So even if your motor encoder, if your motor encoder is at NDAT 2.1, then I would need to bring a second encoder in to channel 2 on the drive or the module in order to have a chance at achieving SIL3. So the combination of encoders is very important when it comes to using this particular module. My advice is if you have a new application coming up, I would just make sure that the motor you've chosen is NDAT 2.2 for the feedback. That's the easiest way to go, if you ask me. So encoders are supported that way. Now splitter cables are also available for the drive encoder. So what you're able to do is use one of these splitter cables here, and then here's this one with a single pin. So what that's there is to monitor the encoder power supply, right? So you want to make sure that the encoder power supply, or you want to check to ensure the integrity of the encoder power supply. So there are 2 different versions of this splitter cable. There's this one with a single pin, and then there's this other one with flying leads coming out of it, and that's used with sine cos encoders. So know that you can split a sine cos component of an NDAT 2.1 or hyperface to be used with the module. So that's what these splitter cables are used for. I have not used them. I haven't the need to do that with my particular setup, but know that they are available. So here's an example of encoder wiring. This is kind of a busy slide here, but and again, this is in the installation and operating manual, which you can download from our website, but it calls out pretty specifically what the wiring needs to be. And again, this particular one shows your NDAT signals coming in, it looks like. Oh no, it's a Syncos. So Syncos encoders. So again, I'm not going to go through this in great detail. This is in the installation guide that you can download from our website. That would be a good time to take a break. Let's take our 10-minute break here, and I'll come back online at 11. Does anybody have any questions to this point? Feel free to speak up if you do. I think you guys can unmute yourself. Raj, can you unmute yourself, or do I have to do that? Okay. I got you. Okay. We're going to take 10 minutes, and I'll see you at 11. Okay. What I'm going to talk about now is using the safety module itself. The first section I went through today, most of that information came right out of the installation and operating guide for the MiS safety modules. And while I'm talking about manuals, there's actually two. There is a getting started guide, which actually contains a practical example of how to create safety functions. I believe there's an example in that manual of network safety. And then there's the installation and operating guide, which is where the technical details and things come from. So, all right. So to configure the module, we're going to be using Connect software. Well, okay. To create a safety setup. And a safety setup consists of a combination of machine safety functions, or MSFs, safe inputs and outputs, and Boolean logical conditions that are arranged to either prevent a potential machine safety circumstance or to mitigate the consequences that might result from it. So, unlike our other integration modules, the configuration of the safety module must be done by a single user that is identified with a user ID and password. So again, this module is very different from the other integration modules in the sense, because it is a safety module, there is security involved. And the first part of that security is you must create a user ID and password. And the user ID and password can be changed a maximum of 7 times. After that, the module must be factory reset. So as you're developing your application, you want to use care to not change the user ID and password, certainly not 7 times. Otherwise, it'll have to be factory reset. So that's different. Now, the module architecture here, kind of a 100-foot view here, is like you see here, and this kind of shows the paths to things. And the thing that I wanted to point out, first of all, is that there isn't a path. You see from the outside world network here, Connect software, right? Ethernet. There isn't a path directly from here to the module. Now, what I'm going to show is we're going to be putting a configuration together, and we're going to be putting it in test mode first. Obviously just to test to see if our setup is what we want to have happen. But when you put it into run mode, you're going to want to monitor the, these safe inputs and outputs. So I'm going to show you tomorrow, I'll show you a method of how you can do that. But as a architecture here, the other thing I would also point out, it's pretty common to have some sort of an external controller involved in these kind of applications, whether it's a safety PLC or a EtherCAT PLC, what have you, to sort of do the sequencing and things like that, depending on what your application is. So the application I'm going to be demonstrating is pretty simplistic, but I'm thinking these applications can be pretty involved if you need them to be. That's not a true, well, the internal functions are not accessible, but the status of the inputs and outputs, they are accessible. All right, so I'm going to show you how to do that. So the workflow, when you're using this module, the workflow is to commission the drive as normal using either keypad or Connect software. And by that, I mean you're going to set up what operating mode you're in, RFCA, RFCS. You're going to choose the source for the speed reference. You're going to set up your motor. You're going to set up your encoder on the motor if there is one, your digital I/O, and then you do an auto tune. So it's sort of the normal flow when you're using this module, and then finally save the parameters in the drive. After that, now we will create a safety setup using the MiS programming tool that's built into Connect software. We had a previous generation of safety module that used software from a third party. It was pretty cumbersome and difficult to use. This implementation is, I find it to be easier. So this procedure holds true for both discrete safety profiles and networked. So whether you're using EtherCAT or CIP with an Allen Bradley processor or PLC, you'd still just set the drive up as normal, then we'll do our safety setup. Now here are some motion safety functions. These are the MSFs that I have referred to. These are icons that are taken right out of the software. So I'll flip over to the software here for a moment, and I can show you what that looks like. So here we are in Connect. I'm offline right now, but if I go to the safety setup area and I go to functions, what I'm going to be describing are these. And you'll notice there are acronyms involved, right? So that's what I'm referring to when I'm saying motion safety functions. So the first one is an STO, safe torque off function. And as the name implies, it prevents the drive from generating torque in the motor. The drive's DC link stays energized, allowing for a fast restart. So these are organized by braking and stopping motion safety functions. If you have a fail-safe holding brake, you can use the SBC, which is safe brake control. So you can use that in conjunction with safe torque off for the safe control of an electromechanical holding brake. Another one is safe operating stop, or SOS. Keeps the energized motor in a safely monitored standstill condition. Now, again, is there a set way that these should be used? Is there any sort of rhyme or reason? No, there is not. You are free to utilize these functions in the way that you have seen fit to come up with your safety setup. So we have safe operating stop, we have safe stop 1. So safe stop 1 here, as you see, will be allow a controlled stop of the motor before removing power via the safe torque off. So with the safe stop 1, we will configure it to decelerate the motor, after which time we will disengage the safety circuit or the safe torque off. Safe stop 2 is a little different. This one allows a controlled stop of the motor, which is the same as this one, followed by a safe operating stop condition. So this combines this motion safety function with this one here. So safe stop 2 kind of encompasses both safe stop 1 and SOS into one single function that you see there. So these have to do with braking and stopping of the motor. And again, keep in mind, the only thing we're going to do is we're going to open the safe torque off. So we also have speed and acceleration monitoring. Clearly, these involve encoders. Okay, so without a secondary safety encoder or without snooping on your motor encoder, if it's an NDAT 2.2, these are not going to be applicable. So we have safety limited speed, which safely monitors the motor speed to keep it within a specified limit, right? So this is one of the things this is one of the functions that I'm using in the example that I'm going to show you tomorrow, the safe limited speed. We also have safe speed monitor, which provides a safe signal to indicate the motor is operating below a speed limit. So safely limited speed is not a speed limit. A speed limit is safe speed monitor. All right, and I will discuss that more tomorrow because I'm using this. Then we have safely limited acceleration, or SLA. Safely monitors the motor acceleration to keep it within a specified limit. So it's kind of a bad example, but if you have a web application or you have a drive running in torque mode and you don't have the mode and the drive set correctly and the web breaks, well, it could accelerate up to full speed. Well, this would prevent that from happening. It's going to make sure that the ramp rate here is consistent. Then you have safe direction, right? So if you have an application in which the motor cannot move the actuator, whatever it is, in the negative direction, whatever that is, you configure the SDI motion safety function to prevent it from running the quote-unquote wrong way, whatever that happens to be. So this group of MSFs is used for speed and acceleration monitoring. And then again, we have position monitoring down here. Safe limited position monitors the absolute position of the motor to prevent it from moving outside of a specified range. So if you've got an application in which the position of the actuator has to be kept within bounds that you define, then safely limited position would be the one machine safety function that you would want to implement to make sure that that happens. Then we have network safety. And network safety, safe value transfer. Safe position and speed transfer over the field bus, whether it's EtherCAT or CIP, for further processing by the safety controller. So this is what we use when we have and there's a picture of a Rockwell PLC there, so safe CIP safety would be implemented. But when there's network involved, we perform what's called safe value transfer. And then there's some additional functions. STHC3, this is your two-hand tie down, it's sometimes called, or safe two-handed control. If you've got a punch press or something that an operator is using one of these dual two-handed controllers, that monitors the application of your redundant push buttons for that type of an application. This is the other function that I'm going to be using tomorrow, which is a safe emergency stop. So every machine has an emergency stop button. So this function monitors the emergency stop button, and that's what I will be showing you in the application we're going to do tomorrow. So here's a table now that just shows the functions that I just referred to. And you see this instances here. You're going to see when I get into the software tomorrow that some of these, for example, safe limited speed, I can utilize that same function up to 4 times in my setup. So that's what instances mean. So safe direction, I can only use that 2 instances of that. Safe datum is a safe starting position. Okay, that's a datum, a European British term. That's home or the origin. So SDN, I can have 1 instance of that. So you get the picture here. And then it just calls out the defining standards that conform or that are used in conjunction with these motion safety functions. And then we have combinational logic functions. So MSFs can be combined using logic functions to create more sophisticated safety implementations. So these are the abbreviations. I have a safe logic OR, safe NOR, XOR, XNOR, so on and so forth. And, NAND, true, false, things like that. So when you get into a more complex safety setup, you're going to find yourself utilizing these logic functions to produce the results that you expect. So that's why you can have many more instances of these as part of your setup as required. So we're going to build a safety setup using a combination of these safety functions and these logic functions here. We're going to have to end a little early today. I don't want to get into the software just yet. So does anybody have any questions for me today? Or you can use the chat, or you can just unmute yourself, and we'll go from there. Does anybody have any questions? Mike, can you hear me okay?
Yep.
Okay. Mike, do you have anything to add?
No, I do not at the moment. Oh yeah, I do. I wrote a little note. So one thing I wanted to add is, I guess I heard down the road here in the next release of this module, they are going to allow for the firmware to be updated.
Oh, really? Okay.
Yeah.
Oh, wow. Okay. Well, that's kind of handy.
Yeah, because I know it makes it so that it's a little scary for the customers if they can't update the firmware.
Yeah.
Some sort of problem, and they need to quickly resolve it. So that is on the plan to be in the next release, which I was kind of surprised because, like what you
Yeah.
said, it's a safety product, and you probably wouldn't want people to update the firmware, but they decided that it's necessary, and they're going to work through that.
Okay. Well, that's good info. Thank you.
And then the other thing is in the encoders, just a little bit more clarity on the encoder stuff.
Okay.
There's 2 encoder ports on the module, and then you got 2 encoder ports on the drive.
Right.
So
okay.
You can pick and choose which ones you want to use, and that one table that you showed kind of shows all that too.
The combinations and what's supported there. Okay. Yeah, that's right.
And then also there is 4 inputs.
physically.
There's actually, yeah. So
Yep.
there's 8 inputs. There's 4 dual-channel inputs on the module.
Right. Okay.
Okay,
Gotcha.
that's all I got.
All right. Thank you, Mike. Anybody else? Questions? Anderson? Okay. All right. Well, if anybody does have a question, you feel free to email me at your leisure. And tomorrow we'll resume again at 10 a.m. and I will work you through a worked example of a safety setup. So thank you for attending today. Thank you for using our products, and we will see you tomorrow.